Hello there. I recently did a hardware review and teardown of the iRadio UV-98 Plus, which is also the same as the Radtel RT-880. And I've got a lot of people asking me, could you do tests on the transmission power, especially in the HF and CB bands? And also, could you have a look at the harmonics? What's it like at suppressing the harmonics? In other words, how dirty is it? Again, there's a lot of focus on the CB band and whether it could actually be used as a CB or not. Now let's have a recap of the specifications advertised for this. It's quite impressive, isn't it? Look at that, 18 to 64 megahertz and 136 to 520 megahertz. Wow, really? That's all in FM as well, by the way. Well, there's a lot of people which are skeptical about that and say, can it really do that? And you can't blame them. So I'm going to try and do some tests today. And what I thought I would do, I would test the common amateur bands within those frequency ranges. And in every case, I'm going to look at the power output. And then I'm going to have a look at how dirty the transmissions are. In other words, how bad are the harmonics? And I'll be giving focus on how many dB down the second harmonic is. Now, so I don't bore everybody to death during the test, I'll go through the test quite quickly, but at the end, I'll summarize results and take stock and do a review. All right, without further ado, let's go and have a look and see if it does what's on the can. Right, so first things first, I need to have something to protect my spectrum analyzer. So what I'm going to do is I'm going to use this 10 watt 40 dB DC to 3 gigahertz load connected by SMA connectors. Now I'm not going to take the attenuation for granted, so I thought I'd slap it on my nano VNA, check it's flat over the frequency range, and check what the real attenuation is. There you are, you see, it's not 40, it's 41, so I'm going to use that value for my spectrum analyzer. Of course, you've got to calibrate your tools, so I just calibrated the tiny SA. Now, to minimize reflections and matching issues and all that sort of stuff, I'm going to attach this directly to the RF output of my iRadio UV-98 Plus. Let me just see what we need to do that. Okay, I need a female to female connector down here somewhere. Yep, that's the one. Oh, I hope I get this out afterwards. No, my luck, it'd jam in there. Alright, that should be good. This is going to get really hot, isn't it? Testing all the bands. I know it. There we go. Bob's your uncle, already in Bristol fashion. Right now, the lead that I'm using to connect to the spectrum analyzer is the one that's supplied with the tiny SA, so I know it's a good one. Right then, ready to go. Now, we mustn't forget to make sure it's on the high power setting, so go into channel settings, down. Oh, there you are. Right, high power. Yep, done. Right, now let me show you how I did the power tests. So first of all, I set the center frequency to the frequency I want to measure, in this case 18.1 for the 7 meter band, and then a span of 500 kilohertz. And then the level I need to set according to the attenuator, which we measured to be minus 41 dB. And then I'll change the center frequency for every frequency I measure. So let's key it up, 18.1, 17 meter band. And I would take that as around 31.5 dB, roughly, more or less, kind of ish. Right, next into the 15 meter band, 21 megahertz. We got 32.6-ish. Then on to the 12 meter band, 24.9 megahertz, and we got 35.8-ish. Then on to everybody's favorite, it would seem, the 11 meter or CB band, keying up on 27 megahertz, and we got around 34.4. Then on to the 10 meter band at 28 megahertz, and we've got around 35.5-ish. Then into 50 megahertz, and what a disaster. minus 19.2-ish. My God, that's non-existent. Then 4 meters. Now this is outside the quoted range, but we're getting 37.2, which is quite respectable. Interesting. That's in between the advertised bands for transmission. But is it dirty? That's the question. 144 megahertz, which of course is in the 2 meter band. This is really good. 39.6, almost full power there. And then into the 1.25 meter band, 222 megahertz, and I think it's around 21.5 dB. Finally, 70 centimeters, 420 megahertz, and let's call that 38 dB. Right, now let's do the harmonics. How dirty is this thing? So we're going to go all the way back, 17 meter band, 18.1 megahertz. Let's key this up, and we're looking at, I'm going to just focus on the second harmonic. Oh, I forgot to put the level in. Don't forget that. I have to do this every time. 41, minus 41 dB attenuation. All right, let's try again. Okay, so keying up, focusing on the second harmonic, and that looks around, what do you think? Let's call it 20.7. Yeah, 20.7. Quite a few harmonics there. Now on to the 50 meter band at 21 megahertz, and a bit better, minus 22. Then on to the 12 meter band, 24.9 megahertz, so 26.2. Now the ever popular 11 meters or CB band at 27 megahertz. So it looks like we're getting around minus 32.2-ish. Now the 10 meter band at 28 megahertz, so it's looking around 36.2, minus 36.2. Then on to 6 meter band, 50 megahertz. What a disaster. Look, it thinks that the second harmonic is a fundamental because it's higher in amplitude than the fundamental. Oh my God, it's very low output as well. Look, 50 megahertz, 6 meter band is just not happening on this thing. Forget it. Nada. Now, on to the 4 meters at 70 megahertz. Now, this is not inside the specified range, but it is actually working, as you can see, but really badly. Look at that. It's a high output, 37.5 dB in the fundamental, and the second harmonic is only 1.7 dB down. That is a nightmare. And this is a bit scary, right? Because when you think about it, that places the second harmonic at 140 megahertz, which is only just above the airband. So let's say you took it down a notch and you were using this to transmit on, say, what, 67 megahertz? That would mean that the second harmonic would be right in the airband. That is not good, is it? Anyway, moving swiftly on. 2 meters, 144 megahertz. almost perfect, almost full output, and no detectable second harmonic down to the minus 60 dB noise floor. 1.25 meter band at 222 megahertz. Quite a few harmonics there, but you can see that the second one is around minus 36.6 dB, not too bad. Then finally, onto the 70 centimeters at 420 megahertz. You can see quite an obvious second harmonic there at 28.9. So that completes our testing. So I purposely went through those tests pretty fast so I didn't bore anybody to death. But here is the summary, and I've shown the power output in both dBm and watts for your convenience. Now, I'm not going to draw a conclusion on these results and say whether this is a good radio or not, or whether the emissions are bad or acceptable or not, but I just put a few observations out. So yes, it does transmit in HF, as we can see here, but it's all in FM, so I'm not really sure, apart from CB, where you would want to use that. Do let me know in the comments, enlighten me please. But let's consider you do have a use for FM and HF. 17 and 15 meters, it's there, but it's very low in power. And the level of the second harmonic emissions is flirting with danger there, really. Minus 22, minus 20 is not great. Moving on up to 12 meters, so we've got a substantial rise of power up to 3.8 watts, and also an improvement in the emissions of the second harmonic. 11 meters CB, the popular band with everybody, it seems. Unfortunately, the power drops down to 2.8 watts there for some reason. But the emissions improves again down to minus 32.2. Again, don't know whether that's acceptable in your country or not. You should check. 10 meters, power goes back up again to 3.5 watts, so it's reasonable, and the emissions improve again. 6 meters, 50 megahertz, well, there's just nobody home. I don't know what happened there. Maybe the RF output stage is cut off at 50 megahertz to ensure that you're not getting second harmonic emissions from the CB band at 27. Just a guess, who knows. And then moving up to 4 meters. Now bear in mind that this is not in the specified frequency ranges. It fits in that gap between the two ranges. But this one I think is a bit dangerous actually. Like I say, the second harmonic is really strong, just 1.9 dB down from the fundamental. And if you were to play around with this at say 67, 68 megahertz, you might be transmitting all over the airband with your second harmonic. So that's not good, not impressed with that. Up to 2 meters, well, it's just a stellar performer at 2 meters, almost full output, 9.1 watts. And the second harmonic is, you just can't find it all the way down to the minus 60 dB noise floor on my spectrum analyzer. So really good there. 1.25 meters at 222 megahertz. That's another band that's gone out for lunch. Missing in action, don't even bother. And finally, our old friend at 70 centimeters, 420 megahertz. So not bad output, 6.3 watts. But the second harmonic, unfortunately, is creeping back up again, now at 28.9 dBm. And I got ChatGPT to produce some lovely graphs. Look at that. The one in red, by the way, is, of course, the rogue band. The 4 meters, the one that could trash airband with its second harmonics. Now I really like this one. Look at this. This shows you the level of attenuation of the second harmonic with respect to the bands. And this is a bit controversial, isn't it? Is this radio legal, isn't it? Well, I'm not going to get drawn into that, but you can see here I did a dotted line at minus 40 dB. Which I understand by the FCC is the minimum level of attenuation for harmonics for transmitters below 5 watts, Let me know if you know different. Be interested to get your viewpoints. But anyway, with that said, I'd just like to thank you very much for joining me on this little testing journey that we've had. And thank you for the comments which led me to do the test in the first place. I do like getting your feedback, and it does help me make better videos. Let me know if you've got any other great ideas for testing that we can do together. And I'd really like to thank those who subscribe to my channel. That really is appreciated and helps me make more content like this for you. And it also allows you to be notified when I bring new content out. So I'm going to wrap this video up now. So until next time, take great care of yourselves, and 73.